your textbook a lot is going to be the integral of a 1 over x dx. All right, and when we write them in terms of x, then we literally mean 1 over x. Okay, so a formula written in terms of x like that, it literally means 1 over x. Okay, so 1 over x, when you integrate 1 over x, you get the natural log, absolute value of x, and then plus c. All right, so straight memorization on that. If you integrate 1 over x, you will always get natural log, absolute value of x plus c. And those absolute value bars have to be there. Okay, they really have to be there. All right, now, if you remember, I like to write the formulas in terms of u, where u represents a function of x. All right, so then we can also have the integral of 1 over u du. Underneath here, let's say where u represents, I hope I spell that right, represents a function of x. In which case, then, what's that doing? That's going to let us have a sine x under here, or an x squared, or a 2x squared plus 1, or any type of function of x under here. All right. And again, this will still be integrated as the natural log, absolute value of u, all right, plus c. All right. However, you're going to find that we're going to have to do, again, just like we had to do on some of our other integrations, you're going to have to do a u substitution, all right, in order to find out what's being pulled out, or you're going to miss it. All right. So those two right there will show up on our memorization quizzes whenever we come back from the virtual learning. We're back in person again, and we're doing this. Okay. Now, with that being said, I want to take a look probably at a very, very straightforward one, and an exception to the rule. I said that you always have to have absolute value bars. All right, there is a scenario where you're not going to have one. You would be allowed to drop it. All right, and this is that exception here. Let's take a look at what's going to happen if I integrate, say, 2 over x dx. Okay, so the first thing I want to do, I want to get it to this. I want to get it so that I've got a 1 over x, right? So 2, I can pull 2 out in front of my integral. So that's the first thing I'm going to do. I'm just going to pull that 2 out in front of the integral. So I have a 1 over x dx. Okay, now I'm set up for my formula here. All right, I know this exactly is natural log absolute value x plus c. So I'm going to have this 2 right here. I'm going to have natural log absolute value of x and then plus c. All right, so straightforward integration right there. Okay, but we know our laws of logarithms, which basically says what? We can move that back up there. Okay, well, what happens when I square x? If I have a number and I square it, what's the sign of that answer always going to be?
Positive.
Positive. Okay, and this says absolute value of x. Absolute value of x is always positive. Okay, so in this scenario, the only time that I could, if I wanted to, drop the absolute value bars because I'm squaring x. So natural log x squared plus c. All right. In all other scenarios, if I had anything else inside here, if I had x plus 1, x minus 2, x squared plus 4, whatever I had in there, okay, I can't drop the absolute value bars, all right, unless it logically makes sense, and you can take a look at whatever's in there and you can say, okay, no matter what I do with what's inside there, it's going to automatically be positive. All right, so I did this because this specific example is in your textbook. And so I wanted to address it. I didn't want you to think that you could go from here to here and then just automatically always drop those absolute value bars, because you can't always do it. Okay. All right. But that's a pretty straightforward one. Okay. Now let's take a look at one that's got a function underneath there. Okay. So a function. So maybe something like the integral of 1 over of 4x minus 1. Okay. Something more than just a plain x right there. All right. Now you are going to have to do a u substitution, or you will miss the part that gets pulled out of the integral. So you can't just look at this and say, oh yeah, that's a natural log of absolute value of 4x minus 1. You cannot do that. You have to do the u substitution. All right, so I'm going to let u be that denominator. So 4x minus 1. I'm going to take the derivative of both sides. So du equals, what's that going to be, like a 4dx. All right, divide both sides by the 4. So a du over 4 is equal to dx. All right, and then hopefully from here, you've gotten used to this. You've done enough of these that you can see a 1/4 is going to get pulled out. Okay, so now I'm going to come up, I'm going to start rewriting. I'm going to have the integral 1 over, and then I want to replace 4x minus 1 with my u. Dx is du over 4. Okay, so there's where the 1/4 is going to get pulled out. All right, and if you don't do the u substitution, you miss that. So I pull out the 1/4. I do the integral 1 over u du, and u is clearly a function of x right here. All right, so, but we're going to integrate, right? So we know that this integrates to natural log absolute value of u. So I've got a 1/4 natural log absolute value of u plus c. Okay, so there's the actual integration. Now, last step, put it back in terms of x. So throw that back in the middle. So 1/4 natural log absolute value 4x minus 1, and then plus c. Okay, can't forget that plus c. All right, so like I said, the reason, when we do these transcendental functions in the middle of calculus, okay, when it's not an early introduction of this makes it really easy because we're just going back over stuff you already are really good at u substitution. We did that with other types of functions. So now you're just implementing the transcendental functions. All right, let's see. I don't know how many of these straightforward ones. I would venture to say we don't have to do tons of these straightforward ones. All right. Are we good with straightforward ones? Does anybody want me to do another straightforward one? Dead silence is good. That means no one's asking for a straightforward one. Okay, so now let's do one where you have to put a little bit more work into it. All right. Let's suppose I had something like the integral of an x to the third minus 6x minus 20, and then all over maybe say an x plus 5. All right, actually this one really looks like question number 9. What was Monday night's homework or something in that number 9? All right, this kind of looks like that. Okay, I had just put it on the worksheet a little bit too early. Okay, so when you first look at this, you're not even necessarily going to know, oh, hey, it's this, going to use this 1 over x thing. You're not going to recognize it at this point. All right, we got to do something with this rational function. All right, lots of different ways we can do it. It's a rational function, right? So if I wanted long division of polynomials, I could take the top, divide it by the bottom, and then see what it comes out to be to try to simplify it, okay? Which is what we want to do, except I don't want to do long division with polynomials. All right, I want to use synthetic division. All right, it's way faster. All right, so we're going to simplify using synthetic division. And I'm going to abbreviate. Okay, I read the whole darn thing out. Okay, so how do we do this? We remember, because we did this with rational root theorem, we used it a lot last year. We take a look at this. We've got an x plus 5, which means I put the minus 5 inside my box. All right, and then I take the coefficients. Now, what about these coefficients? Do we remember? This is an x to the third. Why did I write a 2 there? I have no clue. All right, this then is an x to the first power. All right, and then this is an x to the 0 power. And I'm missing the x to the third power, remember? And we need every coefficient in descending order. So you've got to catch the fact that, okay, here's my imaginary 1. So I have a 1. All right, for my x squared term, I have to put that placeholder in there or the synthetic division is not going to work. All right, and then the minus 6, and then the minus 20. Okay. All right, and then we add. This comes straight down. That's a negative 5. Add straight down. Negative 5. That's 25. Don't let me screw up. When I add that, I'm going to have a 19. And multiplying this, negative 95. And then adding, coming down, I get a negative 115. All right, now when we were doing the rational root theorem and we were trying to factor it, we wanted a 0 for a remainder. Okay, now we don't care. All right, it's okay. This is the remainder. This is your constant term. This is your x term. This is your x squared term. Okay, so, and I don't even care about this over here because that's not the point. So what I'm going to do is I'm going to take this right here. All right, And this is going to go over what I divided by. This, like I said, is my constant. This is my x term, and then this is my x squared term. So I have taken this expression and I'm going to rewrite it using this. So I'm going to have the integral of an x squared minus a 5x plus a 19. All right, it's a negative. So minus the remainder over what I divided by x plus 5. Okay, and then dx. Okay, so this gives me the rewrite on this expression. So this expression up here is equivalent to this expression right here, because all I did was just divide it out. Okay, and every time you will take the remainder, it goes on top, and then you put it over whatever you divided by. Okay, now this, okay, this part's going to all integrate easy, right? Just straight integration. This, then, I'm going to be able to do my new integral that I just learned. Okay, so I'm actually going to show lots of work here. So let's break this up into two separate integrals because that's a legal move. Okay, so let's integrate x squared minus 5x plus 19 dx. Okay, and then let's do minus, now let's write this as an integral all by itself, the integral of 115 over x plus 5 dx. Okay, let's go ahead and integrate this because that's straightforward, right? So we can just do the integration here. So that'll be an x to the third, 1/3. Okay, this will be an x squared, and then put the 2 over, so it'll be a minus 5 halves. And then that'll be 19x. All right, so this part of the problem straight, like we've always done. Okay, now here, what do I want to do? I want to pull out that 115. I want to then have the integral of 1 over x plus 5 dx. All right, now this is where I can use the new stuff. Okay, now, again, I get myself into trouble here. Give me a second. Get this looking right. Okay. Okay, now, what I would recommend, you're going to get to where you can do this in your head and you don't have to show all this work. All right, but I'm still going to show the work. All right, so what I'm going to do is right here, I'm going to come over here and I'm going to do that integration just so that we're not, because I don't want to think or assume you can do this in your head just quite yet. All right, so we'd have the 115 integral of 1 over x plus 5 dx. I just rewrote. That's all I did there. All right, so what am I going to do? I'm going to let u equal the denominator. So x plus 5. All right, the piece of paper is bouncing all over the place. I'm going to take the derivative of each side. So what's this going to be like? Just a dx? Oh, yeah, just a dx. Okay, so I'm going to come up here and I'm going to rewrite. So what am I going to have? I'm going to have 115, the integral of 1 over a u du. All right, 115 natural log absolute value of u plus c. All right, go ahead and put in u. So 115 natural log absolute value x plus 5 and then plus c. All right, so this is what we've been doing. This is the new stuff. All right, eventually, when there's a 1 up there and there's, you know, like this, why did I not have to pull anything out? Well, because that was an x right there in front. All right, so you can do this on the side because I would like for you to just go straight down as opposed to trying to put this underneath here. Okay, you will get to the place, I'm hoping, to where you can integrate a 1 over, no matter what it is on the bottom, you can just look at it and know what's going to be pulled out. So eventually we'll get there, but until you do, okay, then you can do this over here. So then I'm going to have the 1/3 x to the third minus the 5 halves x squared plus the 19x. Okay, now I'm going to replace this with what it equals right here. So I'm going to have the minus 115 natural log absolute value x plus 5 plus c. And yes, it is a really long answer. Okay. But initially, when we started this, you probably would not have recognized that, oh, hey, it's going to be that new integral that we just learned. Okay. All right. So are we good on that? Everybody good on that?